So the last piece for this lesson is we're going to solve equations and then write equations, and these should both be pretty quick processes. So our first set of directions is determine the roots of each quadratic equation. The first step is in order for it to be a quadratic equation, it must equal 0. So in our first example, it already equals 0. Step 1 is done. Step 2, factor. So we just reviewed all of the different types of factoring. When we have a binomial, we look for difference of squares. In this case, that's exactly what we have. So I set up my two binomials. Square root of x squared is x. Square root of 64 is 8. 1 positive, 1 negative. After we factor, we set each term equal to 0. So this is the zero product property. If you are multiplying two zeros, so notice we have term 1 times term 2 equals 0. That means one of my two terms must be equal to 0. So either x plus 8 equals 0 or x minus 8 equals 0. Then solve each equation, and they end up being relatively simple equations. So my first one, I'm going to subtract 8 from both sides. My second one, I'm going to add 8 to both sides. Now notice that my answer of negative 8 came from my binomial where x was positive 8. So that's kind of where that asylum comes from, is when you set it equal to 0 and solve, you have to cancel that addition by subtracting. And same for my positive 8 answer came from my negative 8 in the binomial. All right, we'll look at one more of these and then we'll learn how to write equations. Step 1, get it equal to 0. So this equals negative 16. So I have to add 16 to both sides in order to set my equation equal to 0. Step 2, factor. This is a trinomial with a lead coefficient of 1. My a value is 1, so it's the t-chart method. I don't really need a t-chart on this one. What multiplies to positive 16 adds to positive 17 is 1 and 16. So with the lead coefficient of 1, I get to just throw those right into my binomial. There's not much work to do when we factor these. Step 3, set each term equal to 0. My first term is x plus 1. My second term is x plus 16. And then we solve each equation, subtracting 1 from both sides and subtracting 16. So the roots of my equation are negative 1 and negative 16. Final slide, as promised, writing equations. So this time the term we use is zeros because we're going to write a function with f of x or y notation. I'm going to keep using the function notation just to keep practicing so that hopefully you get more familiar with it. All right, step 1, use the asylum to put the zeros into factored form. Now remember, we just looked at a case where when we set each term equal to 0, we got the opposite answer from what we started with. That's where the asylum comes from. So when I'm putting this into quadratic equation in factored form, when I put my 2 into the asylum, it becomes negative. And when I put my negative 1 into the asylum, it becomes positive. So here we have a quadratic function, but it's in factored form, and the directions tell us we need it in standard form. Standard form, remember, is the ax squared plus bx plus c. So in order to get it into standard form, we distribute. X times x gives us x squared. X times 1, negative 2 times x, and negative 2 times 1. Combining our like terms, we get x squared minus x minus 2. All right, one more example. We have zeros of 4 and 7. So we're going to start by putting them into the asylum. Remember, it doesn't matter what you name your function. The 4 goes in as a negative, and the 7 goes in as a negative. So now we have it in factored form. We're going to distribute to get it into standard form. X times x is x squared. X times negative 7, negative 4 times x, and negative 4 times negative 7. Combining our like terms, we get x squared minus 11x plus 28. And your U-try problems. If you can't see the bottom one, if for some reason the video isn't working well, remember that these are also on the PDF on my website, section 5.3c.